For most of us, a computer probably seems fast enough if it can run 8K videos or the latest version of Far Cry in 60 FPS without slowing down. However, there are many complicated tasks that require billions of calculations per second, something a desktop with i9 processor can't do. That's where supercomputers come in handy. They offer a high level of performance that allows governments and organizations to solve problems that wouldn't be possible with conventional computers. Today's supercomputers are built with AI, artificial intelligence, workloads in mind. In addition to weather forecasting, climate research, physical simulations, and oil and gas exploration, supercomputers help scientists discover more resilient building materials and study humans' proteins and cellular systems at an extreme level of detail. Usually, the supercomputer's performance is measured in floating-point operations per second, flops. In the field of scientific computations, flops is a more accurate figure than measuring instructions per second. Did you know the first supercomputer Livermore atomic research computer was built for the U.S. Navy Research and Development Center in 1960? To show you how far we have come since then, we have curated a detailed list of fastest supercomputers in the world. They all are non-distributed computer systems running on Linux. Number 12. Sequoia. Speed. 17.1 petaflops cores. 1,572,864. Vendor. IBM location. Lawrence Livermore National Laboratory, United States. Sequoia uses IBM's BlueGene Q servers to deliver a theoretical peak performance of 20 petaflops. It has 123% more cores and is 37% more energy efficient than its predecessor K computer. Although the machine is mostly used for nuclear weapons simulation, it is also available for many scientific purposes, such as climate change and human genome analysis. It has also demonstrated its great scalability with a 3D simulation of the human heart's electrophysiology. Number 11. Pangea 3. Speed. 17.8 petaflops cores. 291,024. Vendor. IBM location. CSTJF Technical and Scientific Research Center in Pau, France. Pangea 3 relies on IBM's AI-optimized high-performance architecture. IBM and NVIDIA worked together to build the industry's only CPU-to-GPU NVLink connection, which enables over 5 times faster memory bandwidth between the IBM PowerER9 CPU and NVIDIA Tesla V100 Tensor Core GPUs than the conventional x86-based systems. The architecture not only improves computing performance but also enhances energy efficiency. The new system uses less than 10% of the energy consumption per petaflop as its predecessor, Pangea I and II. Pangea 3 has various applications, especially in 3 different fields: exploration and development, seismic imaging, development and production models, and asset valuation and selectivity. Number 10. Lassen. Speed. 18.2 petaflops cores. 288,288. Vendor. IBM location. Lawrence Livermore National Laboratory, United States. Lassen is designated for unclassified simulation and analysis. It is installed in the same lab and using the same building components as Sierra, second fastest supercomputer. Although Sierra is a big system, Lassen is a decent size in its own right. It is exactly 1/6 of the size of its larger brother. Lassen's system is contained in 40 racks, while Sierra hogs up 240 racks. IBM PowerER9 processors and 253 terabytes of main memory help Lassen to achieve a PERC performance of 23 petaflops. Number 9. Supermach NG. Speed. 19.4 petaflops cores. 305,856. Vendor. Lenovo location. Leibniz Supercomputing Center, Germany. Supermach NG features 6,400 Lenovo ThinkSystem SD650 direct water-cooled computing nodes with over 700 terabytes of main memory and 70 petabytes of disk storage. It is connected to powerful visualization systems that contain a large 4K stereoscopic powerwall and a 5-sided cave artificial virtual reality environment. The supercomputer servers European scientists of many fields, including genome analysis, fluid dynamics, quantum chromodynamics, life sciences, medicine, and astrophysics. Number 8. AI bridging cloud infrastructure. Speed. 19.8 petaflops cores. 391,680. Vendor. Fujitsu location. National Institute of Advanced Industrial Science and Technology, Japan. This is the world's first large-scale open AI computing infrastructure that delivers 32.577 petaflops of peak performance. It has a total of 1,088 nodes, each containing 2 Intel Xenon Gold scalable processors, 4 NVIDIA Tesla V100 GPU, 2 InfiniBand eDRHCAs, and 1 NVMe SSD. Fujitsu Limited claims that the supercomputer can achieve 20 times the thermal density of conventional data centers and a cooling capacity of 70 kilowatts rack by using hot water and air cooling. Number 7. Trinity. Speed. 21.2 petaflops cores. 979,072. Vendor. Cray location. Los Alamos National Laboratory, United States. Trinity is built to provide an extraordinary computational capability for the NNSA nuclear security enterprise. It aims to improve geometric and physics fidelities in nuclear weapons simulation code while ensuring that the nuclear stockpile is safe, secure, and effective. The supercomputer was developed in 2 stages. The first stage incorporated the Intel Xeon Haswell processor, and the second stage included a substantial performance increase using the Intel Xeon Phi Knights landing processor. It can deliver a total peak performance of over 41 petaflops. Number 6. Piz-Daint. Speed. 21.2 petaflops cores. 387,872. Vendor. Cray location. Swiss National Supercomputing Center, Switzerland. This supercomputer, named after the mountain Piz-Daint in the Swiss Alps, runs on Intel Xeon E5 to 26XX microprocessor and NVIDIA Tesla P100. Piz-Daint utilizes DataWarp's burst buffer mode to increase effective bandwidth to and from storage devices. This accelerates the data input-output rates, facilitating the analysis of millions of small, unstructured files. In addition to its daily tasks, it can handle the data analysis of some of the world's most data-intensive projects, such as data collected from experiments at the Large Hadron Collider. Number 5. Frontiera. Speed. 23.5 petaflops cores. 448,448. Vendor. Dell EMC location. Texas Advanced Computing Center, United States. Frontiera opens up new possibilities in engineering and research by providing extensive computational resources that make it easier for scientists to tackle many complex challenges across a wide range of domains. Frontiera features 2 computing subsystems. The first one focuses on double precision performance, while the second one focuses on single precision stream memory computing. It also has cloud interfaces and multiple application nodes for hosting virtual servers. Number 4. Tian 2A. Speed. 61.4 petaflops cores. 4,981,760. Vendor. NUT location. National Supercomputing Center in Guangzhou, China, with more than 16,000 computer nodes. Tian 2A represents the world's largest installation of Intel Ivy Bridge and Xeon Phi processors. While each node has 88 GB of memory, the total memory, CPU plus coprocessor, is 1,375 TB. China spent 2.4 billion yuan, US $390 million, on building this supercomputer. It is now mostly used in simulations, analysis, and government security applications. Number 3. Sunway Taihu Lite. Speed. 93 petaflops cores. 10,649,600. Vendor. NRCPC. Location. National Supercomputing Center in Wuxi, China. The computing power of Taihu Lite comes from a homegrown several-core SW26010 CPU that includes both computing processing elements and management processing elements. A single SW26010 provides a peak performance of more than 3 teraflops thanks to its 260 processing elements integrated into one CPU. Each computing processing element has a scratchpad memory that serves as a user-controlled cache, significantly reducing the memory bottleneck in most applications. In addition to life sciences and pharmaceutical research, Taihu Lite has been used to simulate the universe with 10 trillion digital particles. However, China is trying to achieve a lot more. The country has already stated its goal to be the leader in AI by 2030. Number 2. Sierra. Speed. 94.6 petaflops cores. 1,572,480. Vendor. IBM location. Lawrence Livermore National Laboratory, United States. Sierra offers up to 6 times the sustained performance and 7 times the workload performance of its predecessor Sequoia. It combines 2 types of processor chips: IBM's Power 9 processors and NVIDIA's Volta GPUs. Sierra is specifically designed for assessing the performance of nuclear weapon systems. It is used for predictive applications in stockpile stewardship, the U.S. program of reliability testing and maintenance of nuclear weapons without any nuclear testing. Number 1. Summit. Speed. 148.6 petaflops cores. 2,414,592. Vendor. IBM. Location. Oak Ridge National Laboratory, United States. Summit is the fastest supercomputer in the world that can deliver 200 petaflops at peak. This is equivalent to 200 quadrillion floating point operations per second. It is also the world's third most energy-efficient supercomputer, with a recorded power efficiency of 14.66 gigaflops per watt. Summit's 4,600-plus servers, which take up the size of 2 basketball courts, house more than 9,200 IBM PowerER9 processors and over 27,600 NVIDIA Tesla V100 GPUs. The system is connected by 185 miles of fiber optic cable, and it consumes enough power to run 8,100 homes in 2018. Summit became the first supercomputer to break the exascale barrier. While analyzing genomic data, it achieved a peak throughput of 1.88 exaops, which is nearly 2 billion calculations per second. The United States aims to develop a fully capable exascale computing ecosystem for scientific studies by 2021, and Summit is a step towards that.